What if the secret to your future career success isn't just what you know, but how profoundly you understand the digital tools shaping every single industry? Did you know that the average person regularly uses only about 7 software applications, despite having over 30 installed on their devices? Yeah, the difference between navigating your work life with frustration and truly soaring with productivity, between just using technology and genuinely mastering it, often comes down to understanding what's really under the hood. Get ready to level up. This deep dive is your essential guide to understanding the tech that's reshaping every industry, really preparing you to lead and innovate. And as we unpack these crucial insights, we want to make sure you never miss a beat. So, if you're looking to position yourself for a bright future in your chosen career, please hit that like button, subscribe to our channel, and maybe share this deep dive with anyone who needs a shortcut to being well informed. And remember, for additional resources that can truly elevate your learning, definitely check out the description below.
Okay, so today we're embarking on a really crucial exploration, digging into the world of program and app use and development. And this isn't just about understanding, how to click buttons. It's about grasping the very backbone of modern business. We'll explore how software actually works, the intricate processes behind its creation, and, crucially, why this understanding is paramount for you as an aspiring business leader. Whether you're managing teams, strategizing marketing campaigns, or making critical financial decisions, a solid grasp of software is basically non-negotiable. Our mission today really is to introduce and develop your foundational skills in applying essential and emerging business productivity information technology tools. We'll cover key areas like word processing, spreadsheets, databases, presentation graphics, data analytics, and effective business-oriented internet utilization. Laying the software foundation. Legitimate use in diverse types.
Okay, so let's start right at the beginning then. Software isn't merely a helpful assistant, it's more like the engine driving every single facet of business today. From the intricate accounting programs managing a company's finances to the dynamic mobile sales trackers empowering field teams. I mean, every transaction, every customer interaction, every strategic decision, it leans heavily on software. But here's the critical foundation you really need to understand. Not all software is created equal, right? Nor is all of it safe or even legal to use. For any business, and especially for you as you prepare for leadership roles, understanding and ensuring legitimate software use is absolutely non-negotiable. It touches directly upon those fundamental IT concepts of security and privacy, which are, well, vital for any professional navigating today's digital landscape.
That's a really, really important distinction because the concept of legitimate use goes way beyond just, avoiding pirated copies. It dives deep into understanding digital rights management, or DRM. Think DRM is kind of a digital lock. It's essentially a set of technologies designed to control how copyrighted digital content can be accessed and distributed. Its primary purpose, to prevent unauthorized copying and distribution. In the entertainment industry, for example, DRM protects movies and music from piracy, making sure creators and distributors get compensated for their work.
Right, that makes sense.
But the implications are much broader than just entertainment. In sensitive sectors like healthcare, robust DRM is absolutely essential for patient data security, safeguarding incredibly sensitive medical records from unauthorized access or breaches. For business leaders, overlooking proper licensing for something like accounting or financial software isn't just a minor oversight, it's a huge risk. It can trigger severe legal fines, lead to catastrophic data loss, and inflict significant security risks on companies. Proper licensing ensures not only compliance with the law, but also the integrity and security of your entire operation. It directly prevents fraud and protects your company's invaluable reputation.
I can definitely see how that plays out. I imagine many might think, well, why pay when there's a free version available or an easy download link somewhere? But from your perspective, what's the most common mistake companies, especially maybe smaller businesses or startups, make when it comes to software legitimacy? And what's the quickest way for a leader to sort of spot that potential risk before it blows up?
Yeah, that's a great question. Often the biggest mistake is simply not fully understanding the licensing agreement or being tempted by what looks like a cost-saving measure. The immediate financial saving of an unlicensed copy is just dwarfed by the potential legal penalties, which can easily run into hundreds of thousands of dollars.
Wow.
Yeah, and that's not even mentioning the reputational damage. The quickest way for a leader to spot this risk is really about embedding a culture of vigilance. Ask direct questions. Where did this software come from? Do we have a valid license key? Is it registered under the company name? Basic checks. And always, Always acquire software from official sources. This isn't just about legality. Pirated software is often a major vector for malware, turning a supposed saving into a potentially devastating security breach.
Okay, so once you've acquired the software legitimately, the journey isn't over, right? You mentioned maintenance. How do we make sure we're using it correctly and securely in the long run?
It's exactly. It starts with acquisition, like we just said. Always get software from official app stores, company websites, or trusted resellers. That's your first line of defense against piracy and malware. Then, the installation process usually involves activation keys or digital licenses that link the software to your legitimate purchase. But the truly critical step, and one that's often overlooked, is continuous maintenance through updates. We're talking about three main types here. Patches, which are small bug fixes or security vulnerability repairs.
Like plugging little holes.
Precisely. Then you have service packs, which are larger collections of updates, enhancements, and bug fixes all rolled into one package. And finally, upgrades, which are entirely new versions of the software, often offering enhanced features and maybe significant architectural changes. These regular updates are absolutely not optional. They are crucial for maintaining security, patching those vulnerabilities that hackers love to exploit, and ensuring optimal functionality. Imagine a critical piece of financial software, right? Neglecting updates could leave it wide open to zero-day exploits, compromising highly sensitive data.
That's terrifying.
It is. Or think about a marketing team relying on an outdated design app. They might be missing out on crucial new features that give competitors an edge. Or worse, their old version could have a known vulnerability that leads to a breach of customer campaign data. For you as a student, keeping your devices updated ensures smooth class presentations and protects your valuable academic work from corruption or loss. And honestly, basic troubleshooting steps, like just restarting an app, checking for updates, running a malware scan, or even a full reinstallation can often fix minor issues quickly, saving you time and preventing project delays.
That's a powerful reminder that set it and forget it just doesn't work with software at all. Okay, now, moving beyond licensing and maintenance, let's explore the different types of software out there. It's not just paid or free, right? Understanding these nuances seems crucial for navigating the digital landscape, whether you're managing a corporate network or just optimizing your own laptop. First, you mentioned native software. That's the stuff that comes pre-installed.
Exactly. Like Microsoft Excel already on a new Windows laptop. It's just there, ready to use out of the box.
Okay. Then there's freeware. So free to use, but still copyrighted.
That's right. Google Chrome is a perfect example. You can download and use it without paying, but Google owns the code and the rights.
Got it. Next up is shareware. This is the try before you buy model.
Typically, yes. It offers a free trial period or maybe free basic functionality, but then requires payment or perhaps it introduces ads for continued or advanced use. Think about Dropbox's free storage tier. They give you a taste, hoping you'll upgrade for more space.
Makes sense. And finally, public domain software. This is completely free, no strings attached.
Essentially, yes. Truly free with no restrictions. Often it's open source, meaning anyone can use, modify, and distribute it without any legal issues. Maybe an open source tax calculator someone built and released would fall into this category.
Okay, interesting distinctions.
And extending that thought, understanding these categories, really goes deeper when you consider their intended use in critical business applications. This ties directly into the diverse productivity tools you'll need to master as a future business leader. We can broadly categorize software into several key types. First, you've got productivity software. Think Excel, Word, Google Docs, absolutely essential for creating business documents, managing projects, analyzing data.
The bread and butter stuff?
Absolutely. Second, graphics and media software, like Photoshop or Canva. Vital for marketing, branding, creating any kind of visual content. Third, personal interest software, like fitness apps, though these can sometimes be adapted for business, maybe for employee wellness programs. Fourth, communications software, Zoom, Slack, Microsoft Teams. Critical for collaboration, virtual meetings, project management, especially now with remote and hybrid work.
Couldn't live without those these days.
Right. And finally, security software tools like Norton, McAfee, various firewalls. These are fundamental for protecting sensitive business data from the ever-evolving threat landscape. Consider how finance teams, for instance, depend heavily on productivity software for reports, complex calculations, strategic plans. Marketing departments. They live and breathe graphics and media software for ad design, video production, brand narratives. And crucially, every manager across the organization needs to understand and enforce the use of robust security software to protect that sensitive company data.
So it touches everyone.
It really does. For you, as you're honing your skills, this means using tools like Google Docs for group assignments, or mastering Excel to analyze data for a case study. Maybe creating complex tables, using sorting and filtering, generating charts, maybe even using pivot tables, macros, or those powerful statistical, financial, logical, and lookup functions to dissect data sets. These applications are fundamental to creating professional business documents, conducting sophisticated data analysis, and crafting impactful multimedia presentations, all core skills you need for success in business.
That brings us to a really crucial question. What does all this mean for your practical toolkit as a future business leader? We've sort of distilled some key insights on essential software you should probably be aware of, drawing from, well, decades of IT experience. Let's look at a few categories and what really matters for your business decisions. When it comes to the indispensable productivity suite, well, Office 365 is pretty much the undeniable industry standard, isn't it?
It really is. Its real power for businesses lies in that cloud synchronization and the seamless real-time collaboration features. Teams can work from anywhere, on any device, together. The integration across Word, Excel, PowerPoint, plus things like OneDrive Cloud Storage and Microsoft Teams, it makes it a true powerhouse for project efficiency.
But there are downsides too, right? From a business leader's perspective, that subscription model means an ongoing cost. And sometimes all those features, that feature bloat, can make simple tasks feel overly complicated.
That's a fair point. Leaders need to focus on training their teams to master the essential tools within the suite, rather than getting lost in every advanced option. And always keep a vigilant eye on data privacy settings, especially given its cloud-based nature. But the value for creating business documents, integrating applications, supporting your learning in word processing, spreadsheets, presentation graphics, it's immense.
Okay, shifting gears to robust security. You mentioned Norton earlier. It seems like it's evolved quite a bit.
It certainly has. For a business, its strength is that comprehensive approach to malware protection, often with minimal impact on system performance, which is key. Modern Norton suites often bundle features like a firewall, password manager, VPN, even dark web monitoring. It's like a multi-layered defense. It's generally a solid, user-friendly option for protecting sensitive business data, aligning perfectly with those crucial security concepts you need to grasp.
What are the watchouts for a leader, though?
Well, leaders should be aware of the recurring subscription cost, definitely, and sometimes potential conflicts with other security applications if they're not managed carefully. You don't want security tools fighting each other.
Good point. And for navigating the, let's face it, complexities of modern digital life, a password manager like LastPass seems, well, absolutely essential these days.
Oh, completely. It directly tackles that fundamental security nightmare of password reuse while making things incredibly convenient and secure. Its core value for businesses is securely storing unlimited, unique, complex passwords in an encrypted vault, and then automatically filling login credentials across devices. This dramatically enhances security, preventing things like brute force attacks and credential stuffing, but also streamlines employee access to various systems.
So better security and efficiency.
Exactly. And that zero-knowledge architecture is a big plus. It means even LastPass can't access your encrypted passwords, which is great for privacy. The main considerations for a leader: the subscription cost for full team features and the absolute need for a robust master password policy. Because if that master password gets compromised, well, that's a significant risk. Despite some historical security incidents in this space for various providers, the value in solving widespread password reuse and boosting overall digital security is just undeniable. It's a key aspect of IT security fundamentals every business has to adopt.
Okay, what about system maintenance and hygiene? CCleaner is a name that's been around for a while. What's its role today?
Right, CCleaner. Its primary business value lies in its ability to effectively remove temporary files, browser caches, system junk, basically digital clutter. This can reclaim valuable storage space and potentially improve system responsiveness, especially on older hardware. It can also help with Windows registry cleaning, though the benefit there is debated on modern systems. For businesses managing a fleet of diverse machines, maybe older ones or ones with limited storage, it's a quick way to perform basic cleanups.
But is it still as necessary now?
Well, that's the important nuance for leaders. Modern operating systems like Windows 10 and 11 have many similar built-in cleaning features now. And some of CCleaner's more aggressive features, if used carelessly, can actually be dangerous. So its utility is still there for, file management techniques, manipulating files and folders, maintaining system hygiene, but maybe more so on older systems or those really tight on storage.
Got it. Now, a specialized tool that often works alongside traditional antivirus, and one I find particularly interesting, is Malwarebytes. What's its niche?
Ah, malware bites. Yeah, for businesses, its immense value comes from its knack for detecting and removing stubborn malware that often slips past conventional antivirus programs. Think of it as a specialist. It's incredibly effective against zero-day threats and really excels at identifying and blocking those annoying, potentially unwanted programs, or PUPs.
The ones that sneak in with other installs.
Exactly, those. What makes it powerful is that it's usually lightweight and can often run alongside your existing antivirus without conflicts, providing a critical second layer of defense. The key for a business leader is understanding it's not typically a complete internet security suite on its own, usually no built-in firewall, but rather an incredibly effective specialist for rooting out nasty malware threats. It really highlights the multifaceted nature of modern cybersecurity. And the free version offers powerful on-demand scanning, which is a fantastic asset to have in your toolkit.
So it sounds like building a really effective software toolkit is about more than just the big names.
Absolutely. A truly effective business leader, or really anyone looking to be productive, needs that well-stocked toolbox of specialized software for various tasks. For creative work, there's GIMP, a free open-source powerhouse alternative to Photoshop for raster image editing, and Inkscape for vector graphics, logos, icons, illustrations, also free and very capable.
Free alternatives are always good.
Definitely. For IT or admin tasks, tools like Wingit act as a package manager for Windows, streamlining software installation and updates across multiple machines. Saves a ton of time. For secure file transfers, WinSCP is a solid, free SFTP client, creating bootable USB drives. Rufus is indispensable, super fast, and can even patch installers for tricky hardware. Even something simple like a fast, feature-rich JPEG viewer that offers lossless rotation can be surprisingly useful.
Little things make a difference.
They really do. For audio work, Audacity is a free, professional-grade audio editor. Podcasters love it. Server administration. PutTT is the go-to free SSH client. And for anyone editing code or even just structured text files, Notepad++ is incredibly versatile. SharpKeys even lets you remap keyboard keys for specialized workflows. Each of these tools addresses a specific need. A leader who understands their utility can empower their teams to be significantly more efficient and productive. It ties right back to mastering those essential and emerging business productivity IT tools. 2. Behind the screens. Software development methodologies. Right, so behind every single app, every piece of software we've just been talking about, there's a dedicated team, and they're following a structured process. It's not random guesswork. It's a carefully guided journey driven by specific methods, defined roles, and a really keen, unwavering focus on the end user. Software development typically involves a diverse team. You've got project managers overseeing everything, designers meticulously crafting the user experience, UX and user interface, UI.
The look and feel, basically.
Exactly. Then programmers writing the actual code, testers rigorously ensuring quality and finding bugs, and IT staff managing the underlying infrastructure. And that user experience, or UX, is absolutely critical here. An app's ease of use, its intuitive interface, how efficient it feels, none of that is accidental. It's the direct result of applying strong UX principles throughout the development cycle. Think about an app you love using how seamless it feels. That's good UX design at work.
Yeah, you just know it when you feel it.
You do. And understanding these roles and the huge importance of UX helps you not only integrate business software applications more effectively in your own work, but also manage projects with a truly user-centric mindset. That's vital for success in today's competitive market.
That's a great point about UX. So many people just focus on the features, not the actual experience of using them. Okay, now let's dig into the mechanics a bit more. Let's unpack this core dichotomy in software development. There are two major methodologies that really dominate the landscape, right? Each with its own strengths and challenges, kind of like choosing the right strategy for any business problem. We're talking about the waterfall model versus agile methodologies.
Exactly. The waterfall model is the classic, the traditional, linear, sequential approach. The analogy I often use is building a house. You wouldn't pour the foundation before the architectural plans are completely finalized, right? And you certainly wouldn't start framing before the foundation is set.
Makes sense. One step fully completed before the next.
Precisely. This model is highly structured, very predictable, and moves step by step through distinct phases. It usually starts with requirement gathering and analysis, documenting everything the system needs to do exhaustively. Then comes system design, defining the overall architecture. Next is implementation, where the system is actually built in small units. This is followed by integration and testing, putting those units together and rigorously testing them. Finally, there's deployment to the customer and ongoing maintenance for fixes and enhancements. A key characteristic is that each phase must be fully completed and signed off before the next phase can even begin. No overlapping allowed.
Okay, so what are the big pros and cons there?
The strengths of waterfall are definitely its structured nature. It's predictable, relatively easy to understand and manage. It provides clear stages, defined milestones, and ensures good documentation, which can be vital for compliance or auditing. However, the challenges are significant. It's notoriously slow and inflexible. If requirements change after a phase is done, which happens all the time in the real world, it's very difficult, time-consuming, and costly to go back.
Yeah, sounds like a problem.
It can be. This leads to high risk for complex or innovative projects where you don't know everything up front. And crucially, you don't get any working software until very late in the cycle. The client doesn't see tangible progress for a long time. For business applications, waterfall still has its place, though. It can be useful for compliance-heavy projects, think government, healthcare, maybe finance, where requirements are very stable, well-documented, and unlikely to change much.
Where predictability is paramount.
Exactly, where adherence to strict regulations is the top priority. You can compare it to planning a big semester-long assignment with fixed deadlines, research, outline, draft, final, each step done before the next. It works, but its rigidity is a major drawback in dynamic environments.
That brings up a good point. While Agile gets a lot of praise for flexibility, are there specific business scenarios where waterfall might actually still be the best choice, maybe even strategically better than Agile, especially for a leader who really values that predictability and sticking to a plan?
That's a really crucial leadership question because it's rarely as simple either. Waterfall truly excels when requirements are exceptionally clear, well-defined up front, and genuinely unlikely to change. Think about building a system for a very specific, unchanging regulatory reporting process. Or maybe a project where the technology is very mature, the risks are well understood, and the client specifically requires extensive documentation at every single stage for auditing. In those cases, the structured, sequential nature of waterfall can minimize surprises and ensure a predictable outcome. And for certain mission-critical, low-variability projects, that predictability is precisely what some business leaders need to prioritize. It's about matching the methodology to the project's specific nature and the business's risk appetite.
That's a really helpful nuance. But as you said, in today's rapidly evolving world, flexibility is often king. And this is where agile methodologies come in as a potential game changer, right? Prioritizing collaboration, customer feedback, rapid delivery.
Exactly. Instead of that rigid, linear plan where you wait ages for the final product, Agile uses a flexible, iterative approach. It works in short, time-boxed cycles, often called sprints, typically lasting 1 to 4 weeks. The goal is to continuously build, test, and improve small, functional pieces of software during each sprint.
So you get working software much faster.
Much faster and more frequently. This ensures the software evolves based on real-world needs and feedback. It allows teams to respond quickly to changes in the market or user requests and ultimately deliver high-quality features that users actually want. What's more, Agile testing isn't just a phase tacked on at the end. It's integrated throughout the entire development cycle right from the start.
Catching bugs earlier.
Precisely. This proactive approach helps catch bugs and address issues early on, rather than waiting until the very end when they're much harder and more expensive to fix. This significantly improves reliability, security, and that all-important user centricity.
Okay, so Agile isn't just one single method then.
No, not at all. It's more like an umbrella term, covering several powerful frameworks, each with its own specific practices and emphasis. Two of the most common ones business leaders should definitely know are Scrum and Kanban. Scrum, for instance, focuses on managing tasks within small, empowered, cross-functional teams, usually around 7 to 9 people. They work through those short sprints, typically 1 to 4 weeks long. Key roles include the Scrum lead, or Scrum Master, who helps organize the team and removes obstacles, the product owner, who builds and prioritizes the list of features needed, the product backlog, and the Agile team itself, who self-coordinates to get the work done during the sprint.
Sounds very team-focused.
Highly team-focused. Scrum practices involve maintaining that product backlog, selecting high-priority items for the sprint backlog, having quick daily stand-up meetings for updates, and crucially, delivering potentially shippable working product functionality at the end of every single sprint. Kanban, on the other hand, is more about visualizing workflow. It uses a board, often with columns like to do, in progress, done, to track tasks. It emphasizes limiting the amount of work in process at any one time to improve flow and reduce bottlenecks. It fosters continuous collaboration and ongoing learning and improvement.
More visual, less structured around sprints.
Generally, yes. It's about continuous flow rather than fixed iterations. And there are others too, like extreme programming, XP, which emphasizes technical practices like pair programming and frequent releases, especially good when requirements are volatile. Adaptive software development, ASD, focuses on continuous adaptation and learning. The dynamic software development method, DSDM, prioritizes delivering on time and budget. And feature-driven development, FDD, centers on designing and building specific features in short cycles. They all offer different ways to achieve that core Agile philosophy.
And it really does sound like a philosophy more than just a set of rules. You mentioned Agile operates on 4 core values that seem like a fundamental mindset shift for leaders. Can you recap those?
Absolutely. They really capture the essence. The 4 values are, first, individuals and interactions over processes and tools. Basically, valuing human connection and collaboration more than rigid systems or specific software. Second, working software over comprehensive documentation, showing progress through functional products rather than just generating endless paperwork. Makes sense, right?
Yeah, show me, don't just tell me.
Exactly. Third, customer collaboration over contract negotiation. Continuously engaging with a customer as a partner to ensure the product truly meets their evolving needs, rather than sticking rigidly to an initial contract. And fourth, crucially, responding to change over following a plan. Embracing adaptability and flexibility, because, let's face it, the market will shift, user needs will change, and your strategy needs to be able to pivot with it.
That last one feels particularly relevant today.
It really is. And building on those values are the 12 principles of Agile methodology. They get into more detail, but if we distill them, maybe 3 overarching takeaways emerge for a business leader. First, there's this intense focus on continuous value delivery and customer satisfaction. This means delivering valuable working software frequently, maybe every few weeks, not waiting months or years. It means embracing changing requirements, even late in the game if it adds value. And constant collaboration between business folks and developers.
Keeping everyone aligned.
Constantly. Second, there's a deep commitment to empowered, high-performing teams, creating an environment where individuals are trusted, supported, and can self-organize, prioritizing face-to-face or effective virtual communication, and recognizing that working software is the real measure of progress. And finally, Agile champions sustainable development and continuous improvement. Teams aim for a pace they can maintain indefinitely, avoiding burnout. They focus on technical excellence and good design, and they regularly reflect on how to become more effective and adapt their processes. These principles really equip you, as a future leader, to approach problems with an adaptive mindset. It's crucial for integrating business software effectively and making rapid adjustments based on real-time feedback. It's almost like applying what-if analysis from spreadsheets to your entire development strategy.
Okay, so what does this actually look like in practice? Take us through a typical Agile cycle for a business project.
Sure. The Agile software development cycle is essentially an iterative loop. It starts with concept planning, where you gather high-level requirements, define the overall vision and goals. Then comes design, but it's usually a more flexible framework than a rigid blueprint like in Waterfall. The heart of Agile is development, which happens in those short incremental sprints we talked about, building small pieces. After each sprint, there's rigorous testing to find bugs and ensure the features work as intended.
Integrated testing, right?
Integrated testing, exactly. Then comes deployment, potentially releasing that working increment of software to users. And crucially, there's a constant feedback review loop with customers and stakeholders. This continuous input feeds directly into iteration. The product is constantly improved and refined based on that feedback in subsequent sprints. Think about building a new mobile banking app. Instead of a year-long project to build everything, an Agile team might work in 2-week sprints.
Okay.
Sprint 1 might focus just on the login screen and viewing account balances. After 2 weeks, they test it, maybe get immediate feedback from a user group on usability.
Real users early on.
Real users early on. Based on that feedback, they adjust. The next sprint might tackle transaction history, again with immediate testing and user input. This constant engagement and rapid iteration keeps the project tightly aligned with user needs and market demands, ensuring the app actually solves problems and stays competitive.
That makes a lot of sense. But it can't be all sunshine and roses. What are the limitations or potential downsides leaders need to be aware of with Agile?
That's important, yes. While Agile offers incredible benefits like enhanced collaboration, higher product quality, immense flexibility, lower risk, faster ROI, continuous improvement, and that customer-centric focus, there are also significant limitations to consider. Estimating the total effort and cost for large, complex projects upfront can be very challenging in Agile, leading to uncertainty.
Harder to budget.
Can be harder to set a fixed budget and timeline initially. Yes. The focus on working software can sometimes mean less formal documentation, which might create knowledge gaps later, especially if team members leave. Agile's huggy dependence on continuous customer feedback is great, but if that client input is slow, unclear, or inconsistent, it can really derail a project.
Garbage in, garbage out, kind of.
A bit like that, yes. The constant changes, while a strength, can also introduce unpredictability in project duration and cost compared to Waterfall's plan. And the fast-paced, demanding nature of sprints can, if not managed carefully with that principle of sustainable pace, lead to team burnout. Understanding these nuances helps you, again, describe how software is developed and gives you valuable insights for applying that what-if analysis mindset to real business scenarios, preparing you for complex project management decisions.
Okay, so beyond the big two, waterfall and agile, you mentioned other specialized approaches.
Right. There's rapid application development, or RAD. It's known for being fast and cost-effective, especially suited for smaller projects where requirements are pretty well understood and stable. It really prioritizes quick delivery and uses iterative prototyping heavily. Then there's DevOps. This isn't strictly a development methodology like Agile, but more a culture and set of practices that blends software development, dev, and IT operations. Ops.
Breaking down silos.
Exactly. It focuses on automation, collaboration, and continuous integration and delivery, CI/CD, throughout the entire software lifecycle. DevOps excels at enabling rapid, frequent, reliable releases, though it's worth noting some users or businesses, depending on their needs, might actually prefer a completely finished, highly stable product up front, rather than dealing with constant, ongoing updates that require frequent user adaptation.
Interesting trade-off.
It is. For business applications, DevOps is perfect for entrepreneurs launching apps quickly and iterating based on live user data. Get to market fast, refine continuously. RAD, on the other hand, might be ideal for quickly building internal tools or maybe e-learning platforms where the initial scope is contained and speed is paramount. Each method offers a distinct strategic advantage depending on the context.
That leads nicely into the startup world. You mentioned they often adapt these methods.
They absolutely do. If we look specifically at the dynamic, often chaotic world of startups, project management takes on a unique flavor. Startups, with their high failure rates, but also their focus on highly innovative, often untested products, have very distinct needs. They almost always gravitate towards agile approaches because of that product novelty, the high market uncertainty, and their critical need for flexibility to pivot quickly.
Survival depends on it.
Pretty much. What's really interesting is that startups often don't follow by-the-book methodologies like pure Scrum. Instead, they frequently use ad hoc practices. They might pick and choose individual methods or techniques from different methodologies, a bit of Scrum, a bit of Kanban, maybe some XP practices, and then tailor them precisely to their specific, constantly evolving company needs. This ingrained adaptability is absolutely key to their survival and growth.
So it's about adapting the playbook, not just following it blindly. And you mentioned 3 overarching themes for success in startup software development. These sound like really valuable insights for aspiring entrepreneurs listening.
They really are. The first theme is agility and maturity. Early-stage startups, laser-focused on speed and getting that minimum viable product, MVP, out the door, think startup. Lean startup or design thinking principles naturally use very lightweight, informal methods. They pick and choose practices, tailor them heavily. However, as these startups begin to scale and grow, a clear need emerges for more formalization, better documentation, clear communication protocols, defined processes. This structure becomes essential to support growth and efficiently onboard new team members.
So they mature their processes over time.
Exactly. But the methods they use must always retain that core flexibility and reactivity. Tools like Kanban boards for visualizing work, sprint planning for focused efforts, maybe practices from XP or FTD for quick feedback loops remain crucial. It's a balance between structure and flexibility that evolves. The second theme is all about empowering and valuing people. This means a huge emphasis on continuous customer input, feedback, and approval. Rapid prototyping and user testing are key here to validate ideas early and often.
Talking to customers constantly.
Constantly. Equally important is empowering the team members themselves, letting them experiment, learn from failures quickly, and make decisions autonomously. This is often fostered through informal face-to-face communication, especially in co-located teams, allowing for lightning-fast problem-solving. And finally, the third theme is tool support and usage. Startups find software tools incredibly useful, not just for building their product, but also for supporting their methodological practices.
Tools for managing the process itself.
Yes. Tools for tracking key performance indicators, KPIs, managing dynamic documentation, facilitating seamless communication, enhancing real-time collaboration. These tools should ideally be flexible enough to support that increasing formalization as the startup matures, growing with the company. Imagine a tech startup rapidly iterating on an app idea, constantly getting user feedback, letting their small, integrated team drive decisions quickly without rigid hierarchy. That's the vibe. Understanding this helps business students like you approach problem solving and make recommendations in any business setting, especially if you dream of launching your own venture. This knowledge is crucial for using goal-seeking and what-if analysis effectively in a fast-changing market. 3. The developer's toolkit. Languages, tools, and strategies.
Okay, so we've talked a lot about managing the process. Now, what about the actual creation of software? It all boils down to language, right? But not English or Spanish.
Exactly. It all starts with programming languages, the fundamental instructions that tell computers precisely what to do. At the most basic level, deep down, computers only understand machine language. That's pure binary code, just ones and zeros, directly executed by the processor.
Pretty hard for humans to read.
Extremely hard. One step up is assembly language. It uses symbolic instructions like ADD or MOV that correspond to specific machine operations. It's slightly more readable, but still very hardware-specific. Then we move into procedural languages like C or Fortran. These allow programmers to write code as a sequence of steps or procedures, abstracting away some of the hardware details. And in the modern era, we have powerful fourth-generation languages, 4GLs, like Python, SQL, and Ruby. These are even higher level, often more English-like, and designed so you can accomplish complex tasks with less code.
And it seems like each level makes programming more accessible.
Exponentially more accessible, and also more powerful for solving complex business problems. Take Python, for example. Its versatility makes it an indispensable tool for data analysis, directly connecting to learning outcomes around data analytics. You'll use it to manipulate large data sets, find trends, build predictive models, generate those actionable business insights.
So not just for hardcore programmers anymore.
Not at all. Similarly, SQL, structured query language, is the absolute backbone of database management. It lets you create, manage, and query vast databases, another critical skill for any leader dealing with information. Think about banks using SQL to manage massive customer and transaction databases securely and efficiently. Or you, as a student, learning Python to analyze market data for a project, turning raw numbers into business intelligence. These languages are fundamental enablers for future leaders to interact with, understand, and get value from information systems.
Okay, so knowing the language is step one. But programming isn't just about the language itself. It's about using a whole ecosystem of tools that really boost development, right?
Hey.
The craftsman's toolkit.
Absolutely. A modern developer relies on a sophisticated arsenal. First up, you have editors. Think of these as your digital workbench for writing code. They're lightweight applications specifically designed for writing and editing code, often providing features like syntax highlighting, making the code easier to read, and basic auto-completion.
Any popular examples?
Oh yeah, Visual Studio Code, or VS Code, is incredibly popular, free, open source, huge library of plugins, built-in Git support, integrated terminal. It's fantastic. Sublime Text is another favorite, known for being super fast, lightweight, and having great features like multi-caret editing for making the same change in multiple places at once. And Ultra Edit is a powerful, versatile option, great for handling huge files, multi-language support, and advanced search and replace functions.
So if an editor is the workbench, what's next?
Then you have integrated development environments, or IDEs. If an editor is a workbench, an IDE is like a full-fledged factory. IDEs are comprehensive software suites that bundle an editor with many other tools like compilers, which translate your code, debuggers, which help find errors, build automation tools, and often version control integration, all into a single, unified interface.
So everything in one place.
Everything in one place. It provides a seamless, highly productive environment for the entire coding, testing, and deployment process. Prominent examples include the JetBrains IDEs. They have specialized ones for different languages, like IntelliJ IDEA for Java, PyCharm for Python, WebStorm for web development. They're known for intelligent code assistance and great integrations. Another major one is Eclipse IDE, a long-standing open-source option, particularly strong for Java, with a massive plugin ecosystem for other languages and powerful project management tools.
And businesses use these extensively.
Oh, absolutely. Companies rely on IDEs for building complex internal systems to streamline their operations, and critically, for developing the customer-facing applications that drive engagement and revenue. They're essential for professional development.
All right, you mentioned debuggers, compilers, interpreters in passing there. These sound like the unsung heroes working behind the scenes.
They really are the unseen heroes. Debuggers are essential tools for finding and fixing errors or bugs in your code. They let developers step through the code line by line, inspect variables, and pinpoint exactly where things are going wrong. Invaluable. Compilers and interpreters are the translators. They take the human-readable code written in languages like Python or Java and translate it into the machine code that the computer's processor can actually execute.
What's the difference between them?
Generally, a compiler translates the entire program into machine code before you run it, creating an executable file. An interpreter, on the other hand, translates and executes the code line by line while it's running. For business relevance, these tools are the guardians of accuracy and reliability. Imagine a payroll system with a subtle bug or a finance firm losing money due to transaction errors from faulty code. Debuggers, compilers, and interpreters are the critical first line of defense against these kinds of digital disasters.
Okay, so teams are writing code, debugging it, but how do they manage all these changes, especially when multiple people are working on the same project? Sounds like it could get chaotic fast.
It absolutely could, and that's where version control systems, VCS, come in. You might also hear them called source code management, SCM, or revision control systems. A VCS is basically software that tracks and manages changes to software code over time. It's absolutely essential for modern development teams. It lets them work faster, smarter, and crucially, prevents the conflicts that inevitably pop up when multiple people edit the same files. A VCS keeps a complete long-term history of every single change, who made it, when they made it, and usually a note explaining why they made it.
Okay, why is understanding VCS important for me as a future business leader, not just for the coders?
Great question, because it directly impacts project management, risk, and overall efficiency. 3 key reasons. First, the complete long-term change history. Every modification, creation, deletion, edit is recorded with author, date, and purpose. This is invaluable for figuring out why a bug suddenly appeared or when a critical feature was added or changed. It also lets you easily revert back to older working versions if a new release causes problems, which is huge for business continuity.
Like an undo button for the whole project history.
Exactly, a very powerful undo button. Second, VCS enables branching and merging. This allows multiple developers, or even one person trying different ideas, to work on independent streams of changes, branches, without messing up the main codebase. You can develop a new feature on a branch, fix a bug on another branch, all simultaneously. Once the changes are tested and ready, they can be seamlessly merged back into the main line. This is fundamental for efficient feature development, managing different release versions, and allowing teams to work in parallel without stepping on each other's toes.
Keeps things organized.
Highly organized. Third, it ensures traceability. Modern VCS often integrate with project management and bug tracking tools like Jira. This means you can link every code change directly to a specific task, feature request, or bug report. This helps everyone understand the purpose and design rationale behind the code, making future changes safer and more accurate. For a leader, this translates to better accountability, improved project visibility, more accurate time cost estimations, and ultimately better resource allocation and financial planning.
So where does all this version-controlled code live?
It typically lives in cloud-based repositories hosted on collaborative platforms. The most popular examples you'll hear about are GitHub, GitLab, and Bitbucket. These platforms not only store your code securely, often with backups, but they also provide crucial tools built around the VCS. Things like code review workflows, pull requests where changes are proposed, discussed, and approved before merging, issue tracking, and project management features. They foster that collaborative development environment.
And this relates back to our core skills.
Directly. For you as students, learning to use a platform like GitHub for collaborating on coding assignments or group projects is a practical application of demonstrating proper file management techniques in an online environment, and it's key to integrating business software applications effectively in a team setting. It's a skill employers increasingly look for.
Okay, so we have languages, editors, IDEs, debuggers, version control. What else is in the modern developer's pipeline? It feels like things are getting more automated.
Heavily automated and incredibly powerful. Beyond just writing and tracking code, the modern pipeline uses a suite of tools working together. Build automation tools are essential. They automate the repetitive tasks of compiling code, running tests, and packaging the application for release. Think of tools like Jenkins, Gradle, Apache Maven, CircleCI, TeamCity, Spacelift. They're often the backbone of CI/CD pipelines.
CI/CD.
Continuous integration and continuous delivery or deployment. It's an automated process that streamlines how software is built, tested, and released, making updates much faster, more frequent, and more reliable. Build tools make this possible. Then there's containerization and orchestration. This is huge. It involves packaging an application and all its dependencies, libraries, system tools, everything it needs to run into a lightweight, portable container.
Like a self-contained little box for the app.
Exactly. Docker is the leading tool for creating these containers. This ensures the app runs consistently across different environments, developer laptops, testing servers, production servers. And Kubernetes is the leading tool for orchestrating these containers at scale. It automates deploying, scaling, managing, and even self-healing containerized applications across large clusters of servers. Very powerful stuff.
Wow. And AI is involved now too?
Increasingly, yes.
Mm.
AI coding assistants like GitHub Copilot or Codium are becoming common. They use AI to offer intelligent code suggestions, autocomplete blocks of code, and even help write documentation or debug errors. They can significantly boost developer productivity. And underpinning almost all of this modern development is the cloud. Scalable cloud platforms like Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP, provide the flexible computing power, storage, databases, and hosting infrastructure needed.
It's a complex ecosystem.
It is. But you see these tools everywhere. Game companies use IDEs like Unity for complex 3D games. Startups live on GitHub for collaboration and open source work. Large companies use sophisticated IDEs and CI/CD pipelines for their critical internal systems. Finance firms absolutely rely on rigorous debugging and version control for secure, error-free transactions. Understanding this whole toolkit is crucial for integrating business software applications effectively and even for using web-based technologies to conduct ethical business research, especially when leveraging open-source tools and platforms for innovation.
Okay, wow. So, what have we really learned from this deep dive today? It feels like we covered a lot of ground. We've definitely unpacked how software is just the absolute backbone of modern business. Starting from, the crucial importance of using legitimate software, keeping it updated, understanding all those different types and how to maintain them. We explored the transformative power of development methodologies, contrasting that predictable waterfall with the super adaptive Agile, and even touched on specialized frameworks like Scrum and Kanban. And we saw how this robust toolkit, programming languages, powerful IDEs, essential debuggers, indispensable version control like Git, and all these advanced automation tools isn't just for the hardcore developers anymore. It's absolutely essential knowledge for you, the future business leader, to navigate, influence, and really innovate in whatever industry you choose.
We started this whole journey by asking if the secret to your future career success lies in understanding technology. And, well, I think the answer is emphatically yes, doesn't it? By really grasping the intricacies of program and app use and development, you're moving beyond being just a passive user. You're transforming yourself into an informed decision maker. You're ready to leverage technology strategically, to innovate, to streamline operations, to lead your teams and organizations forward effectively. This knowledge equips you to apply those essential productivity tools we talked about, but also to critically engage with the emerging technologies that are going to define tomorrow's business landscape.
Yeah, absolutely. This deep dive has been packed with insights, analogies, practical takeaways, hopefully helping you level up your understanding and prepare for the opportunities ahead. If you found value in our conversation today, please don't forget to hit that like button, subscribe, and maybe share the deep dive with your networks, anyone you think could benefit. And remember, all the additional resources we mentioned, links to explore further, they're all in the description below, so you can definitely continue your learning journey and deepen your expertise there.
And as you step forward into your chosen career path, maybe consider this final thought. In this constantly evolving digital landscape, how might your understanding of these development methodologies, maybe specifically Agile's profound emphasis on adaptability and that continuous feedback loop, how might that empower you to not just respond to change, but to proactively drive innovation and really redefine what's possible in your industry?
The future of business isn't just about what you know, it's truly about how you apply technology to make things happen. Thanks so much for listening.